Today, we would like to introduce a prototype of Lightnovo RG low-frequency Raman spectrometer. Low-frequency Raman range below 200 inverse centimeters, also known as terahertz Raman, is an exciting spectral range containing information about intermolecular vibrations. In addition to RG Raman spectrometer form factor, the low-frequency Raman will also be available on optical breadboards. It could be easily reconfigured to meet the customer's needs. This is very practical for our customers at universities as well as at industrial research laboratories. The breadboard setup consists of off-the-shelf mechanical components, Lightnovo optical elements, and Lightnovo electronics, which is controlled by Lightnovo MirrorSpec software. The low-frequency spectral range is especially relevant for pharmaceutical industry to study crystallinity and polymorphism of the samples. Another industry benefiting from low-frequency Raman would be semiconductor industry, for example, to study organic semiconductors as well as layered semiconductor alloys, analyze phonon modes of quantum dots. In the polymer industry, the low-frequency Raman will provide the information about structural properties of products. Biomedical diagnostics will also benefit a lot from low-frequency Raman. Now we'll do some measurements. We have the following samples. Sulfur, a reference sample for Raman spectrometer's calibration in low-frequency range according to the ASTM E1840 standard. Calcite, a reference sample for testing the resolution of Raman systems according to the ASTM E2529 standard. Paracetamol, a reference sample for calibration of Raman systems according to the ASTM E1840 standard, as well as according to European Pharmacopoeia. Polystyrene, another reference sample again from the ASTM E1840 standard and from the European Pharmacopoeia. Okay, let's take the sulfur sample. We adjust the focus a little bit, and now we see a strong signal in low-frequency Raman range. Here we can see the lines of 219 wave numbers, 153 wave numbers, 85 wave numbers, 50 wave numbers, and as low as 26.9 wave numbers. The 26.9 wave numbers line is clearly resolved. We estimate the cutoff of the system as 25 wave numbers. Now we move on to calcite. Here's the 1085 wave numbers line of calcite. Now let's zoom in on the line. We can use full width half height of the line to estimate the spectral resolution of the system as 5 inverse centimeters according to the ASTM standard. Here's a paracetamol tablet. Let's focus on it and improve the signal level. Now we can clearly see a typical spectrum of paracetamol with multiple lines across the spectral range. The Raman bands in low-frequency range below 200 wave numbers provide the information on crystallinity and polymorphism of the sample, which is extremely valuable for the quality control in pharmaceutical industry. Now let's take this polystyrene bottle and let's measure it. As you can see, the setup allows to measure the samples of different shapes and sizes. We slightly adjust the focus to improve the signal. Here you can see a typical polystyrene spectrum with an intense 1001.4 wave numbers Raman line. And here's the low-frequency Raman range, with some Raman bands providing the information on the structural properties of the sample. This spectral range is extremely important for the process control in polymer industry. Thank you for your attention.